In previous video, I show you this magic hexagon that shows all the basic trigonometric identities. And in this class, we're going to do the next job. We're going to use that to verify basic identities. Okay, so what does that mean is usually I would verify the left side, the expression on the left side equals to the right side. Okay, the way to do that, I start from one side. I choose one, either left or right. Usually I choose the one looks complicated. I try to simplify that to see whether I can get the other side. So once you want to verify, you start from one side and then you do the work. Okay, use all those identities as long as you, let's say you start from the left side, and then at the end, if you get the same expression as the right side, then you can tell yourself, you said, yeah, it's verified. Okay, okay, so that's it. That's basically what we're going to do in this class. All right, what does that mean? Let me give you one example. I'm going to give you several examples. Okay, so the first one, I ask you to verify secant x multiplied by cotangent x equals cosecant x. All right, now if you have this hexagon graph, you're going to see that yes, secant times the cotangent, of course, is the cosecant. So you can just verify this basically based on your understanding about those identities. However, there's another way to do it. So what you need to do is you start from the left side equals to secant x times the cotangent x. This step is optional. You can copy the question or you don't really need to. If you don't really remember all those, or if you're not given this, then you can just change everything to be sine and cosine. So we know the secant is 1 over cosine x, and the cotangent is cosine x over sine x, right? And then when you go ahead and do the multiplication, you cross out the cosine x, so you get a 1 over sine x, and that is cosecant x, right? And that is your right side. So you can say verified. Your job is done. Okay, your teacher will give you the credit for this question. All right, so that's what you verify. This is very simple. Okay, so let me do the number 2. I also do verify, so I'm just lazy. I just don't need to do verify. I just tell you, okay, I need you to verify this. I need you to verify that secant negative x multiplied by cotangent negative x equals cosecant negative x. Okay, now did you notice that right now this is not the same as that one? Look, even looks very similar, but here's x, here's negative x, x negative x, x negative x. So you have to use the even odd function property. So let's do that. So my left side, you can tell very easily that your left side is more complicated, looks complicated than the right side. All right, now for the secant negative x, is the secant x even or odd function? If you remember that, the secant and the cosine this way, and that they have 2 underlines, so they are even function. Therefore, secant and negative x is the secant just x. Okay, and the cotangent is an odd function, so that would be negative cotangent x. Okay, and then we bring the negative to front, so I have a secant x times cotangent x, and a secant times cotangent is cosecant x. Okay, and cosecant x, when you're doing this, when you're doing your simplifying, or when you work on the left side, you always keep your eye on the right side. You try to make this at the end looks like that. once you get here, because we know the cosecant x is an odd function, so that will be the same as cosecant of negative x, and that is right side. We're done, right? So you prove that the left side equals the right side. So you can say verified. You're going to be very happy. Okay, so far so good. All right, we're going to work on the number 3. Again, I ask you to verify this. I ask you to verify sine x minus sine x cosine square x equals to sine cube x, sine x to the cube. Okay, once you have this, of course, you're going to start from the left side because that has 2 terms, and the right side has only 1. But however, did you notice that both terms have sine x? And also we have a cosine square. For the cosine square, we do have this rule we can use because we know sine square plus cosine square equals 1. Okay, so let's start from the left side. I factor sine x out because both of them have this factor. And then inside, I will get 1 minus cosine square x. Well, this is perfect because 1 minus cosine square is a sine square. So I have a sine square x times sine square x. So that is exactly sine x cubed, which is the right side. And verified. You're done. Okay. So that's the 3 kind of like a simple examples how to verify the basic identities. So let's keep going. I'll give you some more. So I ask you to verify the following. Let me see the question. I will put sine x over 1 minus cosine x. I want you to show me that it's the same as 1 plus cosine x over sine x. Okay, now the left side and the right side looks very like similar in terms of complexity. Let's just start from one side. So let me just start from the left side. I usually start from the left side. So the left side equals 2. I get a sine x square. Sine x here is 1 minus cosine x. All right, now I have a 1 minus cosine x. I tell you a little trick. You're going to use a squared minus b squared equals a plus b, a minus b. The difference between squares, you're going to use this formula quite often. And the reason I'm doing that is if I have a plus b, if I multiply by a minus b, then I'm going to get a squared minus b squared. And usually we will do that for the denominator. So 1 minus cosine squared. So I will multiply by 1 plus cosine x. Okay, for both numerator and denominator. In that way, you're literally multiply this thing by just 1. So you're changing the look. You're not changing the value. That's why you're very confident to put the equal there. And then your numerator, you get a sine x multiplied by 1 plus cosine x. And look at the denominator. The denominator is 1 minus cosine x times 1 plus cosine x, which is exactly this one, like this one. A plus b times a minus b, you get a squared minus b squared. So you get a 1 squared minus cosine x squared, isn't it? If you are not very familiar with this, as long as you know how to multiply by this, you can use the FOIL method. So you go 1, that's the first by first, O, outer by outer, that was plus cosine x, inner, so negative cosine x, that get canceled out at the end, and then minus cosine square x. And we know this, we know what is 1 minus cosine square x, which is a sine square x. Here, I just copy the numerator. Right. Okay, remember this. You're going to be very familiar with this. Sine square plus cosine square is 1. That shaded triangle. That shaded triangle. sine squared plus cosine squared is 1. Okay, now I have both the sine x in numerator and denominator, so I just clear this up. I cross that out. So the numerator, I have a 1 plus cosine x, and the denominator, I have only sine x, which is exactly the same as my right side. So I am done. Okay, so verified. Okay. All right, now I want you to remember this because we use this quite often. So far, so good? Okay, so that is number 4. And then let's do number 5. Again, I ask you to verify 1 over 1 plus sine x plus 1 over 1 minus sine x. And that I want you to show that equals 2 plus 2 tangent square x. I have 1 over something, and the right side is a little easier. So I will start from the left side. Okay. Do you remember how do you add two fractions together? For example, if you want to add 1/3 plus 1/2, do you get the least common denominator in this case, which is because 2 and 3, they are prime to each other. So I'm going to get a 2 times 3, which is a 6. And then we're going to change the numerator because the 3 multiplied by 2 to get 6. So here you're going to multiply by 2. And the second term, because 2, you multiply by 3. So you get a 5 over 6, right? Because that is something extra. But here we have two kind of like a fractions, but they have different denominators. So we find the least common denominator. And in this case, it's going to be the product of them. So it's going to be 1 plus sine x times 1 minus sine x. Okay, and the second term, I get the same thing. So 1 plus sine x times 1 minus sine x. Okay. And then the numerator, because this term, if you compare this, is actually multiplying by 1 minus sine x. So we multiply by the same thing in the numerator. And this guy multiply by 1 plus sine x. So I do more 1 plus sine x on top. Okay, now I have the same denominator, and I only need to add the numerator. Did you notice something here? The numerator is 1 minus sine x plus 1 plus sine x. Sine x cancel out. So the numerator, I only have a 1 plus 1. Okay. And then what is 1 plus sine x times 1 minus sine x? Do you remember this? A squared minus a plus b times a minus b, which is a squared minus b squared. So the numerator is 2. The denominator is 1 minus sine square x. Ooh, we're very familiar with this because that is 2 over cosine square x, isn't it? Okay, because for the cosine in the denominator by the reciprocal rule, and what is 1 over cosine? So this one is 2 secant square x. Okay, not done yet, because we need something about the tangent. So if we have a secant square, that will be the tangent square plus 1. So that will be 2 times tangent square x plus 1, which is, if you distribute 2 inside, you're going to get a 2 tangent square x plus 2, which is exactly the same, 2 tangent square x plus 2, which is exactly the same as the right side. So that is the right side. You verified. All right. Now, for this problem, you need to put this to find the least common denominator and then combine them together, and then you simplify that using the rules that was given by this hexagon graph. Okay, so this is number 5. Let me do think maybe I give you a couple of more so maybe you get familiar with this. Okay, number 6. Again, I asked you to verify this. Cosine to the 4th theta minus sine to the 4th theta equals 1 minus 2 sine square theta. I want you to verify the left side equals the right side. So I start from the left side. Do you remember a squared minus b squared, which is a plus b times a minus b, right? And also, do you know that cosine 4th, which is cosine square and then square, right? Because a 4th means a square and a square. So this is actually cosine square theta square minus sine square theta square. So it's like a squared minus b squared type of thing. So that would be cosine square theta plus sine square theta times cosine square theta minus sine square theta. Okay, so we're using this. Now, cosine square plus sine square is 1. So that is 1 multiplied by 1 times anything is the other thing itself. So don't worry about that right now. And we need, look at this, we only need a sine square, but here we have a cosine square. So we change this cosine square as 1 minus the sine square theta. Okay, and then minus another sine square theta. This minus the sine square theta comes from here, and this one becomes 1 minus the sine square. So that is 1 minus 2 sine square theta, twice of this. So that is my right side. So verified. All right, so this is how you do it, how you work on this question. All right, I'm going to give you one more, and then we're done for this session. So the last one looks very interesting. It goes sine x minus cosine x plus 1, sine x plus cosine x minus 1 equals sine x plus 1 over cosine x. You already have headache? I know. Okay, so I would like to pay attention to this left side. The left side is sine minus cosine plus 1, sine plus cosine minus 1. So it's sine minus that. So what I would do is I would multiply by this guy minus 1, and then I do this one plus 1. Do you remember that we always want to have 1 involved, and then we also want to use this a squared plus b squared equals a c squared thing, right? So what I would do is this. Let me see. Left side equals. Let me just copy the given. Let me copy the given part. It's a sine x minus cosine x plus 1. And the bottom, I go sine x plus cosine x minus 1, and then I multiply by sine x plus cosine x plus 1. Let me do that. Okay, and the numerator, I also do the same thing. I multiply by sine x plus cosine x plus 1. So you can see that I'm multiplying the left side by 1. And this is 1. The value of that is 1. So I'm not changing the value, but it's changing the way it will look. Okay, now if you look at this, you might want to see, look at the bottom. I get a something plus 1, something minus 1. So the denominator, I have a sine x plus cosine x square minus 1 square, right? A minus b times a plus b. I get a square minus b square. All right, Now I look at the numerator. Did you notice that here is a sine x minus cosine x plus 1, sine x plus cosine x plus 1. Let me just use a pencil to show you this and this is the same. Okay, can you tell? So we have a sine x plus 1, then plus and minus cosine x. Again, we have this a plus b times a minus b type of thing. So the numerator, I got a sine x plus 1 square minus cosine square x. A lot of signs, plus, minus, you have to be super, super careful. All right, now let me simplify this a little bit. This one, you can either use a FOIL or you can use a plus b square, which is a square plus 2ab plus b square. You can use that formula, okay? So a plus b square, which is a sine square x plus twice of sine x plus 1, then minus cosine square x. That's the numerator. You agree? Okay. And then the denominator, I got a sine square x plus 2 sine x cosine x plus cosine square x, then minus 1. All right. Now, I ask you to take a look at this. This is sine x squared. So I add to this, the numerator, I get twice of sine square x plus 2 sine x. And the new denominator, I want you to look at this and this. Sine squared plus cosine squared is 1. However, you minus 1. So the denominator is very simple. The denominator is only one term, 2 sine x cosine x. We're almost there, right? Do you remember you want something that looks like this? Now, if I look at my numerator and denominator, I notice that I can factor 2 sine x out. If I factor that out, inside I have a sine x plus 1. And then the bottom, I get a 2 sine x cosine x. And of course, I just cross this out, and then I get sine x plus 1 over cosine x. And that is exactly my right side. Okay, so I'll make it a little bit higher so you can see. That's exactly my right side. Okay. I don't know if I can make that even, but it doesn't help too much. Okay, so anyway, verified. I want you to look at this number, number 5. Where's my number 5? My number 5, did you notice that I go 1 plus, 1 minus, and then I find the least common denominator. Here I go 1 minus, then I multiply by 1 plus, and here I go sine x plus cosine x minus 1, I multiply by sine x plus cosine x plus 1. It's very useful if you can remember this. So when you work on the homework questions or your exercises, then keep this in mind. You're going to use this. All right, so far we learned how to use this magic. Where's my magic card? I'm using my magic Hexagon graph to verify all those fundamental identities.